Hi guys, so we're going to do the static libraries together today, and by the end of this video I just pray and hope that you will be able to understand the concept and do everything. I will try my best to give you brief explanation. And yeah, so basically I think you should just go through these results. They are the same thing. Just read about the static library there because it's quite long, and then this one will tell you the difference between them, between the two type of libraries we have, static and dynamic. Okay, so you should do you should check the manual on these commands, okay, see what they are doing as well, right? Okay, so we'll use them and then you would also see how they work. Okay, so good. Okay, so read the instructions that you can use vi blah blah blah, as you know. Don't forget to put a readme. If you are writing an executable file, you should start with your bin bash, right? And then the quiz. Okay, so the quiz says which command is used to create a static library from object files. Okay, so if you are creating a static library, you're going to be using object files to create it, and you're going to be using the AR command. Okay, all right, so which command can be used to list the symbol stored in? I think nm is used. I think you have to have converted it, right, in order to use it. Static library, they are also called an archive file, right? And then runlib is for indexing. Indexing is just like numbering the object file in a static library. All right, so basically let me just kind of give you, I have a jotting that I'm supposed to share with you guys. Okay, probably I'm going to put the link in the description. Okay, so you can just read the jotting. It's very short. I'll snap it, send it to a link, put it in the description so you can check it out. Okay, so it's kind of explained everything. Okay, so um for my jotting I have the, okay, we have basically, let me just give you an overview of everything. You know, when we write a function, let me go to my command prompts here, and yeah, so these are the tags so far, right? So when you go to your all the functions that we've been writing, for example, I think we started function from let me go to this guy, right? All right, so we started writing functions here, right? This one we're executing it and running it. Okay, so this function, right, we test it with a main.c, right? Why is this one not having main.c? Maybe we're not testing it there. Let me go into another. Okay, sorry. Okay, good. So we're having main.c, right? So when we want to run this function, right, we use that wall pendatic extra blah 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 to compile it. But when compiling it, you will notice that it contains the main.c for main.c, right? It contains the for main.c. It contains the function name. Okay, so the for main.c is calling a particular function. So for main.c is calling what is it, for print rev, right? So we'll gcc compile it and then give it this name and then add the function that we want to work with it. Okay, for print rev.c, right? So we kind of do that and it will compile, right? So this is what we do. We compile this, telling it to use this function. Okay, so what if we have so many functions in this main.c, and we want to use that function? Okay, so the Xsense is now creating a library where we store all those functions, and then instead of writing this function, writing the second function, we just use that one. Okay, and then use it to run this for main.c. So that's just what library is all about. So one way is through the static library, right? And the static library will just kind of explain how we compile those files. And one thing you should know is that before this guy will run, okay, it will go through the stages of compilation for C, right? Which is pre-processing, compilation, what's the other one? It start from A. What was it? The last one is linking, I think, and then the third one should be converting it to object file. I can't remember what it's called. Okay, so it goes through that stages, right? Yeah, assembling. Yeah, I think it's assembly. So compilation, assembling, and linking, right? So we have pre-processing, compilation, assembling, and linking, right? So those four stages are the steps in order to for this thing to go. Those four stages would go in the background. GCC will make it go through those four stages. So you have to understand what those four stages do. Pre-processing, you know that it will remove the comments, arrange the codes. Compilation will change it to from one language to another. Assembly would generate an object, and then the object would be linked to libraries, and then it will be executed. But if that is kind of confusing you right now, because I can't really do much explanation right now, is that what you should know that is that when you want to compile this thing, okay, it's going to first convert it to a particular object file, in which it is then linked with this guy. Okay, this one will get to object, this one will get to object, they are linked together, and then it gives you a particular executable file like this, which you can then use, okay, which you can run, okay, where is it, executable file like this one, okay. Yeah, so now like I said, the essence of library is to put this guy together, and then we can just link it with this guy, okay, and then it will give us a executable, right? Good. Okay, so let's just go ahead, and then I will explain some other stuff. All right, so basically if we go through the task, it says create a static library. So this is a static library name, right? They always end with the .a, right? So it is and they start probably majorly with this prefix um, um, lib, and then the suffix .a. So this is the real name you are giving to the static library. It's called my, okay, you are giving it my, but you are going to add this to show that it is a library, and this is the extension to show that it is an archive file, okay, containing all the function. So you have to create a static library that will contain all these functions. You know, I told you that you are combining those functions together so that you can use any one of it in a particular program, right? Okay, so it's going to compile all these functions. Can you see? And you said if you don't, so all these functions are functions that we've already written before in our previous task, okay. So they say you should just do a library for it, for those functions, okay. So that's what we want to do. And then he said if you haven't coded it, because you know that some people won't have done it right, or that you should create an empty ones with the right prototype. So you just put this prototype as a function and create the function name, right? And then don't forget to push your main.h. So you create the function, you have a main.h. Look at, so the main.h would only will have prototypes, right? They've already given you the prototypes, right? Okay, so you have this main.h, okay, and then it should at least contain all the prototype of the above function, okay. So these ones, so we are going to create the prototype, we are going to get all these files, okay, we'll get them. So after then we'll go to the next step on how we compile everything to give us a library file, okay, to make it in a library. I'm just trying to explain it in a better layman term, okay. All right, so let's go into it. So the first thing I'm going to do right now is we have two tasks here. So we'll go here and then we should create this guy, right? So I'll copy this guy, go, I'll cd outside because we have to be in our ALX low level programming, right? Then I will make the directory, right? And then I'll go into the directory, right? There's nothing inside. So the next thing I'll do is I'll create my readme.md, right? And then I'll write about the file. Okay, sorry. All right, so um, creating a static library to use with the main function files full stop, right? And escape, save and continue, release. We have our readme, right? Good. This one is normal practice. Okay, so the next thing is we'll create our main.h, right? So let's create our main.h. So to create our main.h will just have these prototypes, right? So you copy these prototypes, okay? The main.h of the functions that you want to compile together. Okay, so do like vi main.h, right? And then write it. If not defined, you can just do main h, right? And then we'll say if it is not defined, define, right? Oh, sorry, my define is not spelled well. All right. So after that, you can give it space, paste the prototypes, right? Good. And then end if, okay? And then we are good. So if I release it, I have my two files, right? So we've not done magic yet, right? And we are not doing magic anyway. All right, so the next thing is if you haven't done created the function, so we have to get all our functions, right? So we need all these functions that have these prototypes, and this it should contain all the prototypes of the above. So these are the functions, right? These are all the function names, all the functions. Look at, they're having .o here, but normally they're having .c where we wrote them, and I will explain why we have .o here. But just know that these are the functions. So we have about 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 18 19 20. So we have 20 functions. So we've written this code before, right? But if you have not written them, you just have to create these files and put the appropriate prototype in them, and they have to be in Betty compliance, right? Okay, so good. So because what we've written before is already in Betty compliance, so what I'm going to do is I'm going to look for where they are individually, and then I will send them to where we need them. All right, so the first one is 0 is upper dot c. Remember that we are looking for 0 is upper dot c. So I'll copy this guy and then I'll go to this place. I'll say let me find probably outside this directory, okay? And then by name, I want to search by name. I can add a f to it to show that it's free file, but I can just say by name 0 is upper dot c, and it's telling me that I have this file in 0. Who is this? Who is freak? All right, so is this person. All right, so we have this 0x04, we have this one here. So I'll just go there and get this guy, and then don't forget we are sending it to this guy, right? So 0x04, 0 is upper. So I'll cd, let me see if I can go to 0x04 from here. Oh, yes, I can do that. I'll just do dot slash 0x04, okay, and then enter. All right, then I'll see 0 is upper.c. Where is it? 0 is upper.c. Look at it here. Then I'll say copy 0, let me paste it, is upper.c, right, to 0x09, right, static library, and then I'll press enter. I have that already. Okay, so if I go back to my static library and then I do ls, you see I have my 0 is upper.c, and if I check if it is Betty compliance, because what I had before is Betty compliance, it is, right? If I do like this, you see that it is. So clear list. All right, so let us look for the next one. So for the next one, I can just say 0 mem set, right? I'll copy this guy. I'll then do find space. Sorry, I made mistake. I pressed Control. Yeah, dot C, right? Hey, I think I made mistake. Find. I didn't do by name. You get? I didn't do by name. By name, right? Yes. So it tells me that it is in 0x07. So I'll just go into 007 and then I'll copy this guy .c into where? Into my 0x09, right? And then press enter. So I have the second one. So let's go to the third one. I'll go here, then I'll say find by name and then paste the name .c. So it tells me that it is in 0x06, right? 0x. So I'll move into 0x06 and then I'll copy this guy .c into 0x09, right? And then I'll press enter. So we are done with that one. And then let's go to the next one. So I'll say find, let me use my old by name. One is digit.c and it tells me it's in more function nested loop. There's another easier way to get this is to go through the folders one by one, search for all the files there, copy everything, go to the next one. So you just have to go probably 8 times. Okay, all right. So but let's just continue with this one. So what are we doing? It says is in one is digit, right? Is in 0x04. So we go into 0x04 and then we'll copy this guy. One is digit.c, then we'll paste it in 009, right? So let me clear it. All right, so the next one mem pc.c. So I can use the old find .c is in where? 0x07. So I'll cd into my 0x07 and then I'll copy this guy into 009 and then I'll press enter. I'll go to the next one, this guy, right? Alright, so then I'll look for the next one, .c. It says it's in 0x06, so I'll just copy. No, I'll go to 0x06. I'll cd 006. Then I'll copy the name .c and I'm pasting it in 0x09, right? So let me bring my mic closer. Enter. All right. So the next one, 100 a toy. Okay. So I'm looking for this one, 100 a toy. And I'll paste this .c. It's in my 0x05. So I'll cd into my 0x05, and then I would copy 100.c into my 0x09. Okay, so that one too is done. Let me clear the screen. Sorry, I don't need to ls it. All right, so let's go to the next one, and number 2. Okay, so .c 0x07, then I'll cd into 0x07. All right, and then I'll copy this guy .c. You see, monotonous jobs, you can make mistake easily, you know. Yeah, so and then this guy, we copy it, then do what? cd into oh, we've not looked for it. Yeah, .c is in 0x05. cd into 0x05, right? And then we'll copy it into 0x09. Sorry, and then clear it. All right. So the next one is this. So this is the last one for number 2, and then we'll find this guy .c. Is in where? 0x06. So cd 0x06, right? And then we'll copy the guy .c into where? 0x09. All right. Okay. So we're in number 3. So let me scroll up a bit. We're almost done. So copy this guy, cd, sorry, .c 0x02. So cd into 002. Sorry, I didn't put my. All right, and then I will copy this guy .c into my 0x09. Okay, then the next one, 3 puts, copy, then .c 0x05. So I'll cd into my 0x05, and then I'll copy this guy .c into my 0x09, right? Yeah. So then this guy, and then I'll do looking for you. This one is in 0x06. Then I didn't put .c on purpose, so to still find it because we have the executable there. So we have our cd into 0x06, and then I will copy this guy .c into my 0x09, right? Good. So then this guy, I'll 0x07, I'll cd into 0x07. I'll copy this guy dot c into my 0x09, right? So we're number 4, we're almost done. Then I would want to find it. Doesn't exist. .c. Okay, maybe that's not the executable name. All right, so it's in 0x02, so I'll cd into my 0x02, and then I'll copy the file .c into my 0x09. All right, so next one. So we're done with number 4. So I'll cd, I'll find it. It's in 0x07, so I'll cd into 0x07. Then I would what else? Then I would copy this file.c into 0x09. Then let me clear my screen. Alright, let me increase my screen a bit. Alright, good. So hey, let me reduce it, it's too much. Alright, good. So the next one, we'll copy this guy, and then we'll find this guy. Let's see. Alright, it's in 0x07, cd 0x07. Then we'll copy this guy.c into 0x09, right? So the next one, we're getting there. Then we'll find this guy. It's in 0x02, so cd to into 0x02, right? And then we'll copy the guy.c into 0x09. Clear my screen. So 2 more. And let me copy everything. I'll change it to .c. So we'll find and this one is 0x05, so cd into 0x05, right? Then we'll copy this guy.c into 0x09. And then the last one, underscore pucha is in almost everything. So let me clear. Let me to ls, and then look for pucha. So I think pucha is even here. Can you see? It's in from 2 to 8, and we are in 5. So there's pucha in 5. So we just copy underscore pucha.c into 0x09, right? And then enter. Good. So we're done. So so let's go back to our 0x09, right? Yes, so we have all the files inside. Good. So the next thing we're going to do, we run this sorry. Okay, so back to my explanation. I was saying that if we do gcc main dot c um, and then a function like this 2, for example, this function 2 strchr, where is it, why do we have 2 str here? Just 2 str. Okay, we have 2 str, yes, str lindoc. So if that we are trying to compile this function to work with this guy, right, it's going to go through um, series of compilation process, right, which would one of the series would be converting them to object files before it will then link it together and then make it an executable file. Okay, so basically if we want to make this function work, combine these functions together so that they can work with this main.c, we have to first turn it in the first task. You will notice that that's the hello world we did where we were converting to object files for it to stop at compilation process, you understand. So we are going to do this and make it stop at objects so that where we want to execute this one to, we'll turn this one to object, so object merge it together and then it can give us an executable file. Okay, so that's what basically we're going to do. So you first turn all these .c files, all these functions that you want to combine together, you turn them into an object file. Okay, then those object files you save it in a library. Okay, so that library can be matched with a main.c. The main.c will be turned to object file, you merge it together and then it will give you an executable file. Okay, so that's just how it works. All right, so basically the next step now is where is it? Yeah, we're here. We've created the main.c, so we want to actually create the main.o, right? So that's what we'll do. All right, so to create our main.o, all we'll do is we'll gcc, right, and this is the command to create a main.o, right? So you can start mentioning all the names one by one, okay, like that. But to make it faster, because we have so many, I'll just say gcc-c, that's you are creating an object file. We don't want to fully compile everything to compilation stage, and then I'll do my asterisk that all files that end with .c, because I have main.h here, I have .md here, right? So I just want to turn all these ones to object file. When I press enter, okay, so it's taking time because probably that thing was too heavy for it to do, so it was doing it so fast. Yeah, so if I do ls now, I don't know, it's taking time to load, probably my network. You see that every file now has an object file, right? Okay, so we can then, I was creating an assistant, run this command. I think this command should make it ar does there's this command. Wait, I'm coming. Okay, yes, I think we are running too fast. All right, this one is already creating a library already. Okay, so yes, let me clear the screen. Okay, so we have our .c files and we have our what's it called, our .o files, right, object files. So now we can create our library file, right? So to create our library file, remember our library file name is lib. It will start with lib, right, and then my is the name, like I said, and it will end with this. So you can create a library using this flag. So you say ar, okay, that's you're creating an archive called a library. And what do you want to do to the library? you have your library name, you want to create this library, okay, and you are saying that it should there's this description I give to it. Okay, let me check. Okay, so I said if this library, okay, uh, exists before, okay, it should replace. Probably I'm trying to update it, okay, but if it doesn't, it should create it. Okay, that's the RC. So I can use this RC and then to create it, but some people add this S as well, ARRCS, and then the file name. Okay, so they do this and then you press enter. By the time you press enter, it's going to create this empty library. Okay, so you press enter, it's going to create it. So if I do ls, I'll have that libmy.a, right? But the thing is, I want to put all these functions inside this libmy.a, right? So what I'm going to do is still this old function, right? So I'm going to do this old function, and then I'll now start putting all the .o files inside. So I can list everything or just say all .o. Okay, so this one will help me put all the .o to put it inside the libmy. So the libmy will contain all the object file of those functions. Okay, when I press enter, it's still going to be the same, right? All right, good. So the next thing we are going to do is that those functions are scattered. Okay, for them to be numbered and arranged inside that libmy. Okay, so we'll still run a additional command to it. Okay, so run lib. Okay, so let me see if we are already there. Continue all the functions below. Okay, all right, yeah, so let me just run it. So run lib will help us, and then lib, let me copy paste that name because I don't know if it is capital letter L or small letter, libmy.a, and then I press enter. So that one would help it. It's called indexing. It will give it like number one, number two, arrange it so that our compiler can access those functions easily. Okay, so that's the job of run lib. Okay, so we've created this one containing all the functions. Okay, so I don't know if these commands are necessary, but let me just run it on them. Okay, so you can as well. This AR is to what's it called, to, I wrote it somewhere, create, modify, extract. AR is creating. I don't know, I think we already created. I'm not sure this command will work anymore. Okay, so after running that command, it listed all the .o files. I think that's the function of this command, is to list the .o files, and it's showing that it's working correctly, right? So it's like a testing command, I guess. So nm this guy, and I think this one too should do the same thing as it did here. Okay, so you can just run this command too, and then you see, and then we are good to go. So you come down. Okay, I think it ends here, right? It ends here. Okay, so we now have a main.c. Okay, and that main.c is used to test this library. Okay, so you can create this main.c. So I'll create a main.c for testing. Okay, I'll say vi main.c to test if that library is working. Okay, so escape wq ls. All right, so that's my main.c. So the next thing is I'll compile the main.c with, I'll say gcc this, this one is like compilation command. This is the main.c I created. This one is that I'm using a library in this dot, means in this directory. okay, that currently at, and then we have a -l flag, okay, -l flag, okay, and then the name of the library. Remember that I said the name is my, we just added lib and .a to it because that's the standard way. And then we said the output of combination of all these things, okay, of all this command, put it the name output name as quote. So when they run this quote, it should give you this answer, okay. All right, so I think we should just run this guy since we've created our main. So let's just paste and enter. Okay, it worked. And then we'll just run quotes, right? ls, you see we have quotes, and then dot slash quotes, enter, and then we have this. So it's working perfectly. So we can git add, git commit, git push, and then I can just create my git. I can create a git ignore vi.git ignore because I don't want to push my quotes. I'm not sure it's necessary. This step is not necessary, but you can do it if you want. Okay, I've already pressed it, but I think my system hanged or probably the network, so I'm just waiting. If it doesn't work, I'll just have to reload the page. Okay, let me just reload because it's taking too much time. All right, so cd alx low level, and then cdox, I'm supposed to press it at once anyway. So ls-a, because that guy might have created a swamp file. You see, that's created it. So let us remove it. Git ignore. Why I created it was because it crashed while we were editing. So vi.git ignore. This one is not necessary. I'm just creating it. So I want to say it should not quote, right? And our anything that end with dot, no, can't say anything that end with .c because we might want to push those to other .c. All right, so let us git add everything and then git commit. Okay, so what message are we going to give to it? So I'll say, oh, I think this thing is okay, containing all. It's okay like this. Let's just leave it, and then let's git push it. I hope this git push work because my access token expired already. All right. Wait, do we have any conflict? I think my access token expired already, so resolving data 100% complete with one local object. I don't know if it's working, but let's just try this guy and see if it works. Alright, so if it doesn't, then this guy is taking time. It's taking time, so I can just check my GitHub account and see if it is there already. So github.com, and this one is still okay. So we have something to fix. All right, so we have one error, right? And that might be, what should this be? Could it be Betty? So Let me remove my .git ignore first. Okay, and then so it means that the access token still work. And then git commit and git push. All right. So let me see. ls we have our okay, yes, we have our main.h already. We have our main.h, we have our readme.md, Betty. I'm not sure if betty.c would work. That's what I did. Okay, so I did Betty on everything. So let's see. Okay. Betty say we're right for almost everything. Okay, so no error yet. Still loading. Alright. Okay. Are we done? Okay. Main.c. Is our main.c that is having error. But I didn't push the main.c before. I didn't push it before. No description found for the function main. I'm not sure we are supposed to push the main anyway. So let me retry it and see. The Betty is working perfectly. Yes, the betting is working perfectly. So I don't know. Vi, or is this one more thing we are still missing out? Probably there's one more. I'm not sure. I think we're good. Vi. Let me see. I think we're good. So what's left? I'm trying to think. What could be wrong? What could be wrong? Let me see. Okay, let me recompile the stuff. So arc, let me leave my .a, all the object files. Okay, and then add, except probably the files are not complete. Git commit -m all git commit.m update. Let me just put update. Okay. Let me just go to git pull. It's already up to date. Git commit. Are we having this stuff to update what should be committed? Why are we having this guy? Let me just git push and see. Everything's up to date. Yeah, it's correct. So I don't know. Sorry. I don't know. Let's see. 303141 1 2 3 3041. Proceed. So we have 60 1 2 3 4 5 6 1 2 3 4 5 6 7 8. Correct. How many to 1 2 3? So we are 6 3 1 2 3 4 5 6. Correct. 3 1 2 3 4. We should have 8. 1 2 3 4 5 6 7 8. Correct. 4 1 2. You should have 4 4. 1 2 3 4. Correct. 5. We should have 2. 2 5. How many 6? 1. Yes. 9 2. Put chat 2. 9 2. Put chat 2. Main.h. Leave my.a. Main.c. Quote readme. We are correct. So what's wrong? I don't know. Maybe I'm gonna pause it, find what's wrong, and then I'll let you know. Okay guys, I just rectified the problem, and what I did was, if you notice, I veer into my main.h, okay, and I noticed that, let me show you. So I noticed that if you go back to my video, you notice that I added underscore here and I didn't add underscore here, right? So I just deleted this underscore. It took time before I figured this out because I had to check everything little by little, step by step, because I didn't want to waste your time. That's why I had to pause the video. Okay, so yeah, so that's what I did, and I git add, git commit, and git push, and I went to check, and they said congratulations. All right, so basically that's it, and let's go to the next one. All right, so this one, it says that without create a script. So we're going to create a script. You know how scripts executes, when you execute them, they run that command in them, right? So we are going to put a command. It's like we are doing another task, okay, but that all those commands that we'll be pressing, we put it in a script so that when we execute that script, it's going to do it for us automatically, right? Okay, write a script called this, right, that create a static library. So we are creating a static library called lib all. So it means the name of the library is all. This lib and .a has to be the name, suffix and prefix, right? Prefix and suffix. And then from all the .c files that are in current directory. Okay, so we want to create a command. Is just what we've done before, but we'll just put it in a, what's it called, in a script. Okay, so if you look at it, I think it's still the same name, create startlab.sshow. So we'll just copy this guy. And one thing I need to tell you as well is that you don't need to push all these files. Okay, the ones that are needed is the main.h and the libme.this and your readme. With these three, you are good to go. All right, so you can add your git ignore and put that. So I added that to my git ignore as well. Vi, or let me just cut my .git ignore, right? So I said you should not push everything that .o and .c, right? So let us create this guy, right? Create static. So we are creating a script, so we'll do this bin bash, right? Good. All right, so now it says that go back to this guy. Okay, so it says that we should create a script, and then you should be able to do what? You should be able to this name that create a static library, right? It's going to create a static library called lib.a, right? Okay, so from all the .c files. Okay, so the first thing is that all the .c will compile it to .o, right? So we'll just come here, and to compile it we'll do gcc, right? So we can use the flag wall as ALS we use, and then dash pedantic. I hope I'm right because I think it is pedal, so I can just go here and check. Oh, I'm not sure they have it here. I'm not sure they didn't use pedantic here. So I can go to my previous task, or let me just try it. I think it is pedantic. Pedantic, yeah. Dash Wextra. Is this capital letter or small letter? I'm not sure. Wextra. So I want to turn it to object file, right? And all my .c files. Okay. So this Wextra, I want to see how it's spelled, and so let me just go to a project. Okay, so let me go to one of these projects. Let me go from here. Okay, so the previous projects, which one? Let's go to this guy, and we should be able to see the command, right? So it is pedantic wero. Okay, wero. Okay, I think so. Wall pedantic, I think wero extra. So this one is small and this one is large. So hold on, sorry. Yeah, so it is wero extra. So let me just copy this guy, right, up to this point. Right. So I want to make everything a .o file, right, for all my star.c file first, right? Good. So the next thing I want to do is I want to put all those .o files inside my library file. So I'll do AR, right, for archive, and then I can flag it like this, or remove. I might not put that. I'll just do /rc, which means that it should replace, or it should create, right? I don't need to put s, so I can put it if I want as well. And I'll say, I think it is lib all, right, .a, right, and then I'll say all my .o, right. Then after that, I want to arrange it with round lib, right. I want to index it lib all .a, right, escape, right, and then if I ls it, I have the file somewhere. Where's the create static? Let me just copy this file. Copy. Okay, so let me clear. Alright, so okay, it's here. Alright, so the next thing I will change notification. I can just do 66. I think 66 should do, or probably 722 would be nice, and then the file name, right? Good. So if I ls it is now executable. Then if I run it, it's going to perform that task for us. So I'm not trying to do anything, so let me just leave it. Though I think even if we do this second task first, put all our .c here, okay, and then execute it, it's going to automatically do the task for us, except that the name will not be there. So I can just go there, edit the name to libmy.a, and it's going to do it for me. And then I can edit it back to liball.a, and then it's going to accept this guy too. So that can work too. So should I execute it? Let's see. Create. So I've executed it. It's going to take time. Yeah, so if I do ls, I have my liball.a as well, right? So it's working. So well, I don't care. Let me just git add everything. Though I think it's only this guy that you need to actually push. Except wait. I hope the output, they didn't say we should put it somewhere else. Because by turning it to an executable, oh sorry, it's not this guy. Alright, so this guy, we're gonna come back. Okay, wait. Well, execute it and then okay, it's correct. We're correct. So git add git commit -n, and let's call this one what was it called? A script to create static library cross push. Good. So I just did that, and let's hope this one accepts. Okay, so that's all for now. See you guys.